In this presentations, we are going to discuss about the virtualizations in operating system. So, where the virtualizations and operating systems components here. Now, look at the operating system aspects of virtualizations. So, the CPU scheduling, memory management, I/O, and storage, and unique virtual machines migration features. So here we are going to discuss about how to virtual machine schedules the CPU uses when guest believes they have dedicated CPUs, and how can memory managements work when many guests require large amount of memory. So in this OS component for the CPU scheduling, so even single CPU systems acts like multiprocessors horns when virtualized. So one or more virtual CPUs per guest. So generally virtual machines has one or more physical CPUs and number of threads to run the programs on them. So here the guest configured with certain number of the virtual CPUs and can be adjusted throughout life of the virtual machines. And when enough CPUs are for all the guests, the virtual machines can allocate dedicated CPUs and guests, much like native operating systems managing its CPUs. Usually not enough CPUs. Here the CPU overcommitment. The virtual machines management can use standard scheduling algorithms to put threads on the CPUs. Some add fairness aspects. So the OS component is described by the cycle stealing by the virtual machines, and oversubscriptions of CPUs means guests don't get the CPU cycle they expect. So example, consider the time sharing scheduler. So in a guest trying to schedule 100 ms time slice, so each may take 100 ms 1 seconds or larger. So here the poor response times for the users of the guest, then the time of delay clocks are incorrect. So some virtual machines provide the applications to run in each guest to fix the time of day and provide other integrations features. So the OS component memory management is described by the over subscriptions. So it requires the extra management efficiency from the virtual machines. So in here it has three methods of the memory management. The first one is double paging, where in which the guest page table indicates page is in a physical frame, but a virtual machine moves some of these pages to backing store. The second one is installs a pseudo drive device, that's in pseudo device drivers in each guest, so that can communicate separately with the kernel's modes. And the third one is duplications of virtual machines, determining if some page loaded more than once, the memory mapping the same page into multiple guests. So here the IO components of the IO is easier for the virtual machines to integrate with a guest because the IO has lots of variations, but the overall IO is complicated for the virtual machines because it has a many short path for the IO standards OS for the improved performance, and the less hypervisor needs, and possibilities include direct device access. So the networking also complex as the virtual machines and the guests all need network access. So here the virtual machines can bridge, and it's also provide the network address translations. So in this storage management, the both boot device and disk general data access need to provide the virtual machine. So here need to support the potentially dozens of the guests by the virtual machine. So in this type 1, the storage guest root disk and configure informations within the file systems. And this type 2 stores a file in a file systems provided by the host, and in this duplicate files create new guest and it move file to the another systems. So it provide a physical to virtual conversions and virtual to physical conversions for the proper virtual machine storage management. In view of the live migrations, taking advantage of the virtual machines features leads to new functionality not found on general operating systems such as a live migrations. So where it is useful for the resource management in the point of view of it is established connections with the target virtual machines from the source one, and the target creates a new guest by creating the new CPU, and the source sends all read message and read only guest memory pages to the target. The source sends all read write pages to the target, that is making them in a clean manner. So the source repeated the steps of 4. So as a during the steps some the pages were probably modified by the guest and are now dirty. So when the cycles of the step 4 and 5 becomes very short, source virtual machines freezes the guest and sends the virtual CPU's final state, sent other state details and sent final dirty pages and tells target to start running the guest. So this type of migrations process is done with the acknowledgement and the source terminate by the acknowledgement value. So that descriptions, so first establish the connections and send the request read or write. Okay, that request is created in the guest page in the virtual machines, then afterwards it sends the request and send a read and write request page to that guest site, then send the dirty pages. So these steps are sequentially performed. The fourth and fifth steps are sequentially and continuously performed. After the stop conditions, the process going to the terminate state. So the examples for the virtual machine visualizations process is VMware. So in this VMware, workstations run on x86 provide the virtual machines for the guest. So it's run an applications on other native, so installed host operating systems in the type 2. So here the lot of guest possibles include the Windows, Linux, etc. all runnable concurrently. So they are connected concurrently. So it can be allocate the resource individually and worked with the individual process. So the virtualization layers abstract underlying the hardware, providing guest with its own virtual CPUs and memory disk drive, network interface, etc. The physical disk can be provided to guest or the virtual physical disk. So it's an architecture for the VMware. It has the applications layer and the then second layer isn't the guest layer. So here we have the three partitions for the guest. So each guest layer has virtual machines separately and virtual CPUs, virtual devices. So this overall are connected with the visualizations layer. This overthink and overall process is controlled by the host operating system and have the hardware to perform the particular task. So another examples for the virtual machines in Java virtual machines. So here mainly the Java object compiled into a architecture natural byte code. So here the Java is actually store the source code in a class. Okay, so here the class loader is used for that loading process. So it is an user friendly programming environment virtualizations. Okay, Then it includes a garbage collections to reclaim the memory on larger in the use, and it's made faster by just-in-time compiler that run bytecodes into native code and catch them. So that architecture, that's a diagrammatic view of the Java virtual machines. So many class files are available because in the Java code every programs are written in the form of class files. Okay. So in this class files are loaded by the class loader, and the Java interpreter is used to compile that, and from this application's interface is interact with the loader that perform the virtual operations. Thank you.